Hi, so in this video, I'm going to continue talking about the friction force. Let's just get into the note. So here is the, again, the microscopic view of the two surfaces that's in contact. When they're not in contact, of course, there's no friction force. And then when they're not exerted onto the parallel to the surface, there's no friction force. But friction force occurs when you, not just only because you have irregularities, but also you push against each other, right? So that's why there's a friction force. And this force that's applied perpendicular to the surface is called support force. So again, going to review friction force. Friction force depends on one, what was that depends on? And a two. What's the friction force depends on? Friction force depends on one, material property. Of the two surfaces in contact. And also depends on the support force, how much it pushes against each other, right? Let's see. Imagine this case. You have an object and that's on a flat surface. And it's at rest. It's just sitting on a flat surface. Is there any friction force? Do you see, is there any friction force applied? Draw the forces applied on the object that's at rest on a flat surface. No friction force. There is a gravitational force perpendicularly, vertically downward. There is a normal force perpendicular to the surface. They're equal in magnitude and it's in opposite direction. Net force equals 0. That's why it's at rest. Then what happens when the object is in a slight angle? Any friction force. And this object is still at rest. Right? Any friction force applied and it's at rest. Explain why. If there is a friction force or no friction force, why? Explain. And if friction force applied, which direction? What is the direction of a friction force, do you think? And then how large? And what happened? So here, as increase in angle, what happens to the friction force? The object is about to slide. Maybe it's at this is at this angle, it's about to slide. So what's happening? Do we have a friction force applied? Why? What's changing? So let's see the video. Okay. I might not have the voice in. Let's see. Sorry. I don't think you. Not used to have a voice. So the dinosaur is on a flat surface. It should be reading 0. You might not be able to see it, but it's on the dinosaur is at the flat surface. Do you have any friction force applied? We said no. But what happens? It's just the exact same objects. I'm not changing anything. What happens in this case? Okay, so I'm gonna tilt this angle. So it's tilted. So now you see this toy dinosaur is not in motion, but it's on a tilted angle that's 8 degrees. What's happening? What are the forces applied onto this toy dinosaur? Is it still gravitational force and normal force only? If there's a frictional force applied, how much is it applied, in what direction, and why? Why? What is the net force of this dinosaur? This dinosaur is not moving. That means the net force is equals to 0. When the angle of incline is tilted, let's see, like here, right? It's tilted. When the angle of incline is tilted like this, then does the gravitational force change? How about the normal force? What does the friction force depends on? Does friction force depends on the gravitational force, or does the friction force depends on the normal force, or does it does not depend on either of them? The friction force depends on the normal force, the support force. And when you change the angle of incline, right, the friction force, the normal gravitational force does not change, but normal force decreases because the gravitational force is now not pushing perpendicular to the surface as much. And there's now new, another part of a gravitational force, which is parallel to the surface, is increase perpendicular to surface, decrease normal force, decrease. So now you have a pushing force, which is the gravitational force that's parallel to the surface, is pushing the dinosaur along the surface and the normal force decreased. So the friction force decreases and there is the force that's applied parallel to the surface due to the gravitational force that's parallel to the surface. Then you increase, if I increase the plane even more. All right. Okay, so I'm gonna tilt this plane.
Plane? What's a plane? It's a slide.
So if I increase the angle large enough, at 30 degrees in this case, this little dinosaur starts sliding. And it's the angle, that's critical angle, it's the maximum static friction. So static friction increase, in this case, the friction force actually the friction force decrease because the normal force has decreased as the increase in angle, right? Normal force decreases as you tilt the plane to the vertical. So therefore, because of that, friction force also decreases, but the parallel component to push the dinosaur down along the plane increases. So in this case, at 30 degrees, the dinosaur starts sliding and the friction force has changed to the kinetic friction force. This is the demo that to show that friction force depends on the normal force. So this was the demo to show that friction force depends on the normal force, not the gravitational force. And this is the video to show that friction force also depends on the material property of the two contacts. So instead of having just a one toy dinosaur, I have another stuffy, which is the little rabbit that's made of different, it's made of fabric. So it has a different material coefficient, which is the two different contacts material, right? And then if I tilt it. So now I have two objects. Nice. So if I tilt it. I'm going to tilt the plane. So there are two objects made of different materials. I'm going to tilt the plane. You see the angle. Sorry, the angle part didn't work. The angle is gone.
The bunny slided first.
Sorry, the angle didn't work. But as the boys say, the bunny slide first, right? So because the bunny has a different material in contact with the same plane, bunny has a different material coefficient, and then it has a different friction. So the bunny slid first, then differently from the contact than dinosaur. I can write it quickly onto the iPad. So you see here that what happens when you tilt in an angle, right? When you tilt the angle, then object's gravitational force do not change. Gravitational force always stays the same. But when you decompose the gravitational force, one that's perpendicular to the surface and another to the parallel to the surface. So FG parallel, FG perpendicular. Then as you have an increase, this increase as increase in angle. But let's see, this decrease in increase in angle. Therefore, the normal force, which is only the response force from the gravitational force, that's perpendicular to the surface, right? Uh-oh. Hmm? So let's see. And this is going to be the same length as this part. They are the same length. So then there is that decrease in as the increase in angle. Should change all of this to this one is to as, right? Sounds good. So that's why you tilt and tilt and tilt. The friction force decreases as the normal force decreases, and then the push force along the parallel increases. And then you're not exerting any new force, but the object starts sliding. Okay, so I hope you could explain this dynamics of changing an angle, be able to explain it with the static, maximum static friction and the dynamic kinetic friction, also the normal force, changing normal force. What's the friction force depends on? Is that depends on the gravitational force or normal force or nothing else? Different things. You're going to be able to differentiate all these things and be able to explain. All right, I'll see you in a discussion.